Today, we are talking about a totally new way to think about computing. It's a breakthrough that could make our technology not just a little bit faster, but thousands of times faster. And no, this isn't science fiction, this is happening right now.
So let's just start with this wild idea. Imagine computers that are 1,000 times faster and 100 times more power efficient than what we have today. Well, researchers at Peking University have built a new kind of chip that might actually get us there. But to really understand how this is even possible, we got to rewind a bit and look at the huge problem they're trying to solve.
You see, for all their amazing power, our digital computers are kind of stuck. They're in this permanent, massive traffic jam. And the more we ask them to do, the worse that traffic jam gets.
Just think about all the huge things we're trying to do with computers right now. You've got artificial intelligence, next-gen 6G wireless, massive scientific simulations, complex financial models. All of this stuff is just incredibly thirsty for data, and it's pushing our current computers to their absolute breaking point. And here's the real kicker. The problem isn't just about making the processor faster. It's something called the von Neumann bottleneck. See, in pretty much every computer, the processor, the brain, and the memory are in two different places. That means data has to get constantly shuffled back and forth, back and forth. That constant shuffling creates a huge bottleneck, a digital traffic jam that slows everything down, no matter how fast your processor is.
So, what's the fix? Well, it turns out the answer might be hiding in a really old idea called analog computing. Researchers have given it a brilliant modern update that lets it just completely sidestep that entire traffic jam.
Okay, so what's the big difference? Well, digital computing, as you know, is all about the super precise language of ones and zeros. But it's stuck with that physical separation of the processor and memory. Analog computing is a whole different beast. It uses the physical properties of electricity, like voltage levels, to do the math right there inside the memory itself. There's no shuffling data around, which means it's just naturally way faster and more efficient.
So, if analog is so much faster, why aren't all our computers analog? Well, for decades, it's had this one single tragic flaw that made it a no-go for any kind of serious calculation. I mean, this quote from the actual research paper just says it all. For all its incredible speed, traditional analog computing just wasn't precise. You just couldn't trust it to get the exact right answer every single time.
You can think of it like this. Analog was great at giving you a super fast ballpark answer, but for things like scientific research or financial trading, ballpark isn't going to cut it. You need perfect precision. That sloppiness is the main reason digital computing, with its perfect ones and zeros, won the race. Until now.
And that is where this new research comes in. The team at Peking University came up with a hybrid approach that is frankly brilliant. It combines the raw, screaming speed of analog with a super clever way to get perfect digital-level accuracy.
What they figured out is a way to get the best of both worlds. The whole process happens in the super-fast analog world, but it uses this refining process to check its own work until the answer is absolutely perfect.
So here's the secret sauce. First, the chip makes an incredibly fast but kind of sloppy first guess at the answer. Then, and this is the genius part, a second circuit instantly calculates exactly how wrong that first guess was. And finally, it uses that error calculation to correct the answer and immediately does the whole loop again. It just keeps refining itself super fast until the answer is perfect.
Okay, that all sounds great on paper, but you know, the proof is in the pudding. So the team put this new chip through a really tough, real-world style test. They basically set up a simulation of a future 6G wireless network, which is going to be incredibly data-intensive. The goal? Send an image, let it get all messed up with simulated noise and interference, and then see if their new analog chip could put it all back together perfectly on the other side.
So this is what they started with, the before picture. A nice, clean image of the Peking University emblem.
Now this is what they got back after just one cycle of their process. That initial super fast, low precision guess. As you can see, the image is kind of there, but yeah, it's a mess. It's full of errors and noise, fast but definitely not perfect.
But then, watch this. After just one more cycle of refinement, bam! A perfect reconstruction. It's identical to the original. This just proves that the rapid-fire correction process really works.
And get this, when they made the problem even harder, simulating a much larger system with 128 antennas, it only took 3 of these little cycles for the analog chip to achieve the same accuracy as a high-precision 32-bit digital processor. 3 cycles, that's it.
So let's zoom out. What does all this mean for the future? Well, the performance numbers they're projecting are, honestly, they're kind of mind-blowing.
Okay, let's talk raw speed, or throughput. This chart compares their projected analog chip to a single core from a top-of-the-line NVIDIA H100 GPU. And yeah, you're seeing that right. It's not 10 times faster, not 100 times faster. We are talking about a potential 1,000 times increase in speed.
And it's not just about speed. What about power? We all know how much energy these massive data centers consume. Well, check this out. Because the analog chip avoids all that data shuffling, it's projected to be up to 100 times more energy efficient. That is a total game changer.
So by finally cracking this precision problem that's held analog computing back for decades, this research may have just thrown the doors wide open to a whole new chapter in computing. It points to a future where we can finally break through the digital traffic jam, unlocking advances in AI, science, and communication that we can barely even imagine today. The question really isn't if this is possible anymore, but how fast we can make it a reality. Thanks for joining me.